Hello friends, it is a database management system NPTEL course week 4 assignment which is conducted in March 2019. Each assignment of NPTEL course will have 10 questions. Here I am going to explain all the 10 questions in a detailed way so that you can easily understand and you can write the further NPTEL courses exams. Coming to question 1. Identify the correct statement about the decomposition demonstrated below, where PQR are column names. Here, these are the PQR table, means a table, which is decomposed into, say, table 1 and table 2. And say, second decomposition also given one table T, and that is decomposed into two tables T1, T2. Question is about lossy and lossless. Here you observe options are given is 1 is lossless, 2 is lossy, 2 is lossless, 1 is lossy and all. We have to find whether the decomposition is lossy or lossless. We can say a decomposition is lossless if and only if the join of the two decomposed relations, if you join the two decomposed relations, it should give the original relation. Then we can call decomposition is lossless. We'll check each of the options. First, we'll perform join of T1 and T2. We can say T1 join T2. The join of T1 and T2 will be based on the common attribute with equality condition Q equal to Q. Now look, A1, 1 equal to 1 matches, 2 equal to 2 matches. So that the result is PQR, that is A1X B2Y. A1X B2Y. This is T. So the first decomposition is lossless. And second decomposition, we perform join between T1 and T2. The join of T1 and T2 will be done based on the common attribute. What is the common attribute of T1 and T2? Q. Now join always a Cartesian product. 2 into 2 4 combinations to be verified for the condition T1Q equal T2Q. That is 1 equal to 1 true, 1 equal to 1 true, 1 equal to 1 true, 1 equal to 1 true. So the result is PQR, that is A1X. This A1 of T1 is also matched with Y. B1X, it is also matched with Y. So how many tuples are there? 4 tuples. How many tuples are there in the T? 2 tuples. Means it is not producing the same result that was there before decomposition. So therefore, we can call this decomposition is lossy decomposition. And friends, observe A1X is there in the table T. A1Y, this is not there in the original relation. B1X is also not there in the original relation. B1Y there. The join of these two decomposed relations produced some extra tuples. These extra tuples are called spurious tuples. The spurious tuples means suspicious tuples, or incorrect tuples, or wrong tuples. Showing wrong tuples in the database, considered the decomposition is lossy. So that what is the answer for the question? First one is lossless, second one is lossy. So 1 is lossless, 2 is lossy. So answer is option A. Question number 2. Find the functional dependencies that stands valid. Question is about validity of the dependencies on the part of the relation shown below. A functional dependency x to y is said to be valid if whenever the LHS of the dependencies are duplicating, say x1, x1, x1 like this, the corresponding RHS also to be duplicated. Suppose if RHS is y2, this should be same for all these 3 tuples. So keep in mind, friends, if LHS is same, then the corresponding RHS also should be same. But reverse need not be true because dependency is one directional. Fine. Now look, option A, P determines Q. What does it meaning? When P values are same, the corresponding Q values also should be same. But here P values AA same, but Q values 1 and 2, which is different. It means P determines Q is wrong. Option A is wrong. It means not valid. Option B, Q implies P. Q implies P. What does it mean? Whenever Q is duplicating, the corresponding P also should be duplicating. What is Q? 1, 2, 3, 4. Q is not duplicating. P need not be duplicated. So that this dependency is valid dependency. What is a B? Second one, P implies R. What does it mean? When P's are repeating, corresponding R also should be repeated. Now here PAA repeated, corresponding R is XX repeated. Here PBB, corresponding R XX repeated. It means this P implies R also valid. Now question is about valid, then we can say option B is the correct answer. Question number 3. Identify the prime and non-prime attributes of the given functional dependencies. Here friends, understand what is meant by prime and non-prime attributes. Attributes, here I am writing clearly, attributes of candidate key are called prime attributes, okay, are called prime attributes. All the remaining attributes we call non-prime attributes. Here a relation R of Mn, Op, Q, Rst is given, and these are the dependencies. To find prime and non-prime attributes, we need to find what is a key for the relation. And key we determine based on the LHS of a dependency and its closure. What is Q closure? Q, R, S, T, that's it, not all attributes. Q is not a key. You try for Mn closure. Mn closure is Mn, PQRST, Mn, PQRST, but this is not determining O, so it is also not a key. Then try for O closure, O, P, Q and M with QRST, RST, O, P, Q, M, RST, but N is not there, so that O is also not a key. Now what is the fourth dependency? P to M. P closure we will find. P closure is P, M, that's it, not all attributes, not a key. Because no LHS of the dependency closure contains all attributes, no LHS is a key. In such cases, we have to look for the independent attributes. Friends, observe what are the independent attributes. RST are the dependent attributes. Whichever the attributes that are there in the right hand side we call dependents. RST dependents. PQRST also dependent. PQ dependent. M dependent. What is not dependent? Whichever is not there in the right hand side is called independent. What is there in the right hand side? NO. Find the closure of NO. NO, with O we have PQ, with P we have M, with Q we have RST based on the first dependency. With Mn we have PQRST, that is also there. So what is the NO closure? NOPQMRST means all attributes, then we can call it as a key for the relation. Now what is a key? Only one key, that is NO is a key. NO is a key. If NO is a key, remaining all other attributes are non-prime attributes. Look for option A, Mn are prime attributes. Mn is not a key attribute. Option A wrong. On are prime attributes, correct. MPST remaining attributes are non-prime attributes. It is a correct option. Option C, MRPT, these are not candidate keys, so it is not a prime attributes. MNOP, NO is prime attributes, but it is also saying that M and P also prime attributes. It is incorrect. So answer for this question is option B. And friends, actually in the key it is mentioned D, it is wrong option. Actually this NPTEL course even I have written. We mailed this question and reported it is a wrong option, and the NPTEL team they corrected this option also, but actually it is not corrected in the PDF file which provided by NPTEL team. Later they corrected for the correct evaluation. It is incorrect. I will tell you why it is incorrect, friends. Here what is given, Mn plus NO plus NP plus determines the entire attribute set. Anyhow, we proved that NO closure contains all attributes. Friends, check for Mn closure. What is Mn closure? Mn. With Mn, what you can get? P, Q, R, S, T. Right? With P, we will get M. With Q, R, S, T already there. Friends, observe, is Mn closure contains O? No. So that Mn is not a key. That's why this explanation is wrong. So we reported and NPTEL team they corrected. So this is a wrong option provided. So answer for the question is option B. Question number 4. Which highest normal form is guaranteed by the following relation? Which highest normal form is guaranteed by the following relation. Observe friends, department ID is a key. Department ID is a key, and department name, salary are attributes, and all are atomic values. All are atomic values. Because all are atomic values, this relation is satisfying first normal. And department ID is a key, and I'm trying to find a dependency with respect to other attributes. Say department ID is a key means department ID is determining department ID and department name and salary. It is a dependence. And here department name is not duplicating, and there is no duplication in salary. So we don't find any dependence from department name to salary or salary to department. So here what we can expect, only one dependency, department ID. Only one dependency, department ID is determining department name, comma, salary. Here in this dependency, department ID is a key for the relation. Because LHS of the dependency is a key, this dependency is satisfying BCNF relation. Okay, it is satisfying BCNF relation. So answer for question 4 is option D. Friends, here also option B is given by NPTEL team. Later they corrected. Okay, later they corrected. So the correct answer is option D. Question number 5. Relation R of A, B, C, D, E, G. Having the functional dependencies, these are the dependencies given. The question is find the candidate key. When options are given, it is best to find the closure for the option. Now find closure of AG. What is AG closure? AG. With A we'll get B. So B we add it. With B and G, which is already there in the previous closure, we can get E. So we add E. Anything else possible? No. But key closure should contain all other attributes A, B, C, D, E, G. But it is having A, B, E, G. C, D is not there. So it is not a key. So option A is wrong. Option B. A, B, C closure. A, B, C. With A we determine B. With C we determine D. With D we determine G. But are you getting E, friends? With BG we determine E. Okay. It is determining all the attributes. First I conclude that it is a key. Check for option C. AC closure. That is A, C. With A we have B. With A we have B. And with C we have D. With D we have G. With B and G we have E. Based on the second dependency. This is also containing all attributes. We call it as a key. For ABD closure is A, B, D. With A we determine B. It is already there B. With D we determine G. That is also already there. With BG we determine E. This is also there. Now added. And do we get C? No. So that it is not a key. So what were the keys, friends? There are two keys we found. That is ABC, AC. And question is about candidate key. Now candidate key is called minimal key. Minimal key, nothing but no proper subset is a key. In ABC, observe friends, in ABC, A and C together is already key. Because it is already key, so that ABC is not minimal. ABC is not minimal. Because it is not minimal, ABC is not candidate. What is candidate key? AC is a candidate. Answer for this question is option C. So B and D options are wrong. Question number 6. The canonical cover of RABC, where the dependencies are given A to BC, B to C, A to B, AB to C, AB to C. What is canonical cover? Suppose a functional dependency F is given. The dependency we checked which dependencies that are redundant. We have to check. Find some dependency in the F which is redundant. We have to remove the dependencies from F. We call G. Now we can call G is a minimal set of F. G is a minimal set of F. Why? Because every dependency of F you can get with G. Then we can call G is a minimal set of dependencies, which is also called canonical cover. Which is also called canonical cover. Okay. How to find redundant dependencies? Okay. A to BC possible to determine with other dependencies. Whether it is possible or not, we can find by finding the LHS closure. Means A closure we need to find. With respect to other dependencies. What is A closure? B. With B we are determining C. Means with A, with respect to other dependencies, you are getting both B and C. then we can say A to BC is redundant, which is straight away can be eliminated. Similarly, this AB to C you can try with respect to other two dependencies, because anyhow A to BC is already deleted. Now you try, is AB to C dependency possible to delete it? How? You can check by finding the AB closure with respect to that second and third. And keep in mind, first is already deleted, should not be considered again. Now what is AB closure? A, B. With B we have C. It means with AB we are going to get C. This is also possible, so we can call it is redundant. A to B you cannot get alone with B to C. B to C cannot get alone with A to B. So what is left is the minimal set. Now what is left? To B and B to C. This is called minimal set or canonical set. This is also called irreducible set. And friends, remember, sometimes a question may be irreducible set and this may be irreducible set also possible. So answer for the question is option B. Question number 7. R of ABC, these are the dependencies are given. Question clearly given, the table is not in which normal form? We have to find not in which normal form. Normal form of a relation we can find by finding the key. What is a key for this relation? AB is a key. Why? Because AB closure is AB. With AB we determine C. ABC. Okay. And here B is a prime attribute. In C to B dependency, B is a prime attribute. This B you replace with C, so that AC is also candidate key. Now we have two candidate keys. And it is satisfying the definition of 3NF. The definition of 3NF, if X to A is a non-trivial dependency, should be super key or is a prime attribute, either or, any one of the condition. What are the dependencies we have? AB to C, C to B. AB is a super key, means AB is a key, correct? AB is a key. Condition itself is satisfied, need not to check for the second. C is a key? No. AC is a key, C is not a key. LHS is not super key, then it should check with the right hand side. What is right hand side? B. What is B? B should be prime attribute. Prime attribute means attribute of a candidate key. So both the dependencies are satisfying definition of 3NF. We can go ahead with option C. Friends, you may ask why it is not BCNF. BCNF requires LHS of the functional dependency should be super key itself. Here C is not super key, so that we can say it is not BCNF, it is 3NF. So answer for the question is option C. Coming to question number 8. The following relation are, suppose the following functional dependencies holds. These are the dependencies. Now question is the closure of N is. How to find N closure? N closure is N. Now you check N is there in the LHS of any dependencies. Here that you can include its right hand side, Q. Repeat the process. Now either N or Q or NQ together is there in the LHS of any dependency. Yes, there. Q is determining P. Write it. Repeat the process. Now N, P, Q or any combinations of this is there in the LHS of any dependency. NP there in the LHS. So that we determine. Anything else? Now M is not in the previous closure, I should not use this dependency. O is not in the previous closure, I should not use this. So what is N closure? NQPG. NQPG is there with an option B. So answer for question number 8 is option B. Number 9. Following relation guarantees which highest normal form? Highest normal. Clearly values are atomic values, that it is satisfying the first normal form. I have to check with second, third and BCNF also. It is clearly mentioned SID comma course is a key. SID comma course is a key. Observe a table. SID is determining S name. Means wherever SID is repeating, you see friends, the corresponding name is also same. LHS is same. Dependency to hold, its RHS also should be same. Means when LHS is repeating, its RHS also should repeat with the same values. SID is a key, as it is clearly given, it is a key. The dependency SID is determining S name is considered as a partial functional dependency. Why? Because LHS of a dependency is part of key, that we call it as partial dependency. If partial dependencies are possible in a relation, we can say relation is in 1NF itself, but not 2NF, but not in 2NF. Answer for the question 9 is option number 10. Following relation guarantees which normal form? The following relation guarantees which normal form? Because all our atomic values, first we can say it is in the first normal. Because it is all key relation, so it is going to satisfy 2NF, NF, BCNF also. Observe friends, here course teacher subject is a all key relation, and observe the data at one course determining the multiple teachers, 2 teachers. So means one course determining multiple teachers, we can call it as a multi-valued dependency. One course is determining multiple teachers, called MVDs. Observe also that one subject enter pointer taught by teachers. One subject is also taught by multiple teachers. So we can call this is also one multi-valued dependent. So because multi-valued dependencies are there, we can call this relation is in the normal form. These multi-valued dependencies are non-trivial multi-valued dependencies. Because a relation contains non-trivial MVDs, the relation is in normal form. So that answer for the question is option C.